Hey guys, this is Science Day 5. So with Day 5, we're going to be focusing on vision and light. So if you think back, this was with the tokay gecko, and we went through the whole process of how animals are able to see. So remember that it has to start off at the sun, and excuse my dog barking outside. Then the sun will shine onto some type of object. Let's have an object of a cube. And then the light will bounce off the object and into our eyes. Okay? However, once it gets in our eye, remember that the pupil allows the light to go through. The light then hits the light receptors. And remember, the light receptors respond to the light. That information from the light receptors travels through the optic nerve and into the brain. And then the brain takes that information and compares it to its memory so that it knows what it's looking at. It creates an image and then it compares that image to its memory. So you're going to need to know that process to help you with today's science lesson, okay? So we're going to use all of this information to help us answer questions 24 through 27. Predator and prey senses. Animals have several senses that allow them to survive. The senses of predators and prey are different. Dogs and other predators have eyes facing forward. They can see a large area with both of their eyes at the same time. This helps them see things far away. This also helps them see things to the right and left without turning their heads. Many predators have good vision at night. So here we have figure 1 shows the field of vision for a dog. So whenever the dog is looking with both of its eyes, this is what it's able to see. If he looks just to the left side, this is everything that he's able to see. If he looks to the right side, this is everything that he's able to see. But everything behind this, remember we talked about these two side vision being your peripheral visions. This is what you can see without having to move your head and just looking from your left side to your right side. And then everything behind that, we talked about that being your blind spot, which is anything you cannot see at all. So remember, this is your blind spot. All right. Rabbits and other prey animals have eyes on the sides of their heads. They can see a larger area than most predators. However, the area that they can see with both eyes is small. This means that rabbit vision is not very clear. Rabbits also cannot see well at night. So there's our first tidbit of information. Here is our second one. So now we have figure 2, which is the rabbit vision. So you'll notice that the rabbit's eyes are on the side of its head, and so what it can see out front is very small compared to what the dog could see out front. However, look how large the rabbit's peripheral vision is on both sides of its face. That's because the eyes are on the sides. And then the rabbit's blind spot is also very small. Look how small the blind spot is compared to the dog's blind spot. And again, that's because the rabbit's eyes are not in the front of its head, but on the side. So this is its blind spot. All right. Rabbits cannot see clearly enough to identify animals they see. Rabbits rely on their senses of smell and hearing to identify what is in their environment. Rabbits have many more smell receptors than humans. These smell receptors allow rabbits to notice and identify predators from a distance. Table 1 compares the number of smell receptors in humans and other animals. So, here we have Table 1, number of smell receptors in humans and other animals. So, we have humans, rabbits, most dogs, and then bloodhound dogs. And then we have the number of smell receptors in millions. So humans have 6, rabbits have 100, most dogs have 1,000, and then bloodhound dogs have 4,000. So there's our second bit of information. All right, here's our first question. It says use the information in Table 1 to answer the question. So we're going to be using this information in Table 1. Which statement best explains why a dog's brain can process more information about smell than a rabbit's brain can? So here we're talking about smell, and we're comparing it to a dog's brain and a rabbit's brain. So let's look at A. Dogs take in different kinds of information with their smell receptors than rabbits do. Well, here in Table 1, it doesn't tell us that information. It doesn't give us what kinds of information dogs may take in compared to rabbits. So that's not going to help us explain. B, dogs process information from their noses and tongues to learn about their surroundings. Well, again, that information is not covered within Table 1, so that's not going to help us explain it. C, dogs have a smaller range of vision than rabbits do and learn to rely on their memories about smells. Again, we're focusing on Table 1, and Table 1 does not give us any of that information. D, dogs take in more information because they have at least 10 times as many smell receptors as rabbits have. So now we're finally talking about smell receptors. So if rabbits have 100 and most dogs have 1,000, would that be 10 times more? Yes, it would. So D is talking about the smell receptors, and it's given accurate evidence from the table. All right. It says use the information in Figure 1 and Figure 2 to answer the question. So here we pretty much have Figure 1 and Figure 2, but again, if you want some more information, here's Figure 1 and here's Figure 2. But you can see that they pretty much look the exact same. So it says which statements, which that already tells me I'm going to have to choose 2, best explain why the dog is able to see the object more clearly than the rabbit. And it says select 2 correct answers. All right, so let's look at A. It says the image of the object is visible from both of the dog's eyes. So here we have the object. And is the object visible from both of the dog's eyes? Yes, we have arrows that are pointing to both of the dog's eyes. So A would be correct. B, the image of the object is visible from both of the rabbit's eyes. Well, here's the image of the object. However, it's only pointing to one eye. So is it visible from both? No. Let's look at C. The image of the object is visible from only one of the dog's eyes. Well, if we look, here's the object, but it's pointing to both eyes. So would it be visible from only one eye? No. D. The image of the object is visible from only one of the rabbit's eyes. So here's the image of the object, and it's only pointing to one of the rabbit's eyes. So that's showing evidence that that is true. And then E, the image of the object is visible from both the dog's eyes, but neither of the rabbit's eyes. So yes, it is visible for both of the dog's eyes. However, it's showing that it's visible by one of the rabbits, not neither of them. So the second part of this answer choice is wrong. All right, 26. Which statement best describes how a rabbit processes information that is taken in by the rabbit's eye? So this is where you want to think about how humans or any other animals are able to see an object. The light hits the object, the light reflects off the object into the pupil lets the light in, the light hits the light receptors,